Hi, I'm Lindsay.
I'm Kim.
I'm Molly.
I'm Alexa.
And we're the Mythbusters! And we are going to investigate the myth that if you keep your phone next to your credit card, like in your wallet or your pocket or whatever, that the magnet from your phone is going to damage the magnetic strip in your credit card and like damage it and it won't be able to work.
So our phone is a weak magnet, and we're going to compare it with a stronger magnet. We're going to see how the weak and the strong magnet that we got from the physics lab. And we're going to see how these magnets affect the magnetic strips in gift cards that we got from Meijer.
So we got some Meijer gift cards. All 8 of them are the same. So we bought 8 gift cards from Meijer, and we had 4 time slots. So first we exposed magnets for 12 hours. We did 24, 36, and 48. Each time slot had the 2 gift cards, one exposed to the strong magnet and one exposed to our cell phones.
So after we completed all of the time slots, we went to Meijer to test to see if the magnetic strips worked. And then we saw if there was any differences in between the weak magnet and the strong magnet, and we also were able to see if there was any differences in between the different amount of time slots. Hey guys, so I have the 12-hour time period, and we're going to check if these guys work as soon as I finish checking in my groceries.
Insert cash or select payment type. Take your check to cashier and pay station.
I would try card.
Go back.
Insert cash. Please insert, tap, or swipe your card on the pin pad.
Let's try this one. Alright, so in conclusion, the 12-hour ones did not work. Both of them.
Tell me when you're recording.
Good.
Alright, item in the
I had the 24-hour slot, so these 2 gift cards were up against a magnet and my cell phone for 24 hours. I have the hair tie on here just to remind myself which one is which. And we're going to see if this
cash
works.
or select payment type. Please insert, tap, or swipe your card on the pin pad.
Try it again.
That one working?
No, but it says express fees.
I can do the same thing with them as I did with the first one. If I can do that.
That's okay, we can just stay with the other one. Thank you though. Alright, so once again these cards are not working. So our hypothesis is right.
So I had the 36-hour slot, buying my breakfast. And this is the one that was in my phone.
Insert cash or select. Please insert, tap, or swipe your card on the pin pad.
Doesn't work. Doesn't work.
The 36-hour time slot does not work either. So I had the 48-hour one. This was for the phone, and this was for the magnet. Not expecting it to work since no one else's have. Pretty excited. Stay tuned. Also buying my breakfast and turkey. And all right, let's give it a go. So this is the phone one. I'm gonna give it 3 good goes. Phone does not work. and the magnet. In conclusion, the 48-hour time slot does not work either.
Hey guys, I guess you're wondering what is a mag strip and how does it work? Well, a mag strip is one of these little guys, the black on the bottom, and it can be found on your credit cards, debit cards, gift cards such as this one, Starbucks gift cards, or the Meijer gift cards that we used in our video. So the mag strips are composed of iron-based magnetic particles that are about 20 millionth of an inch long, so it's really, really tiny. And these can encode information because the particles can be magnetized in either a north pole or a south pole direction. And as you swipe the card, the information can be aligned and read. So the mag strip has 3 different tracks that each holds a different bit of information, such as your PIN number or your country or your authentication, which allows you to use your card. And in these tracks are leading 0 bits, which are encoded to specify the presence of an encoded magnetic card and provide synchronization pulses to the read head, which is a controller that can decode these pulses into vital bits of information and allow you to use your card. So how do magnets ruin the mag strip? As we well know, magnets can put out their own magnetic field, and this can realign the iron-based particles within the mag strip. So they no longer face the correct direction, and the card won't have the correct information encoded into it anymore, and so you won't be able to use your credit card or gift card. Our experiment showed that the gift cards that were exposed to our phones and to a magnet, so a low magnetic field and a high magnetic field, for any amount of time, the gift cards were affected and rendered useless. So the iron-based particles must have been realigned and can no longer work anymore. And we were wondering why this occurs because, as most people probably already know, you can have your credit card and your debit card near your phone and it won't damage them. So we were really, really surprised by our findings, and we were wondering why this happens. So I did some more research, and I actually found out that there are 2 different types of mag strips. One is called high coversity, and the other one is called low coversity. The high coversity is called HICO, and the low coversity one is called LOCO. So I'll be using those instead because they're much easier to say. So the HICO magnetic strips are the ones that are used in your debit cards and your credit cards and your ID, and things that have a longer lifespan and that are meant to be around for a long time. Whereas the LOCO ones, magnetic strips, they are the ones that have a short lifespan, and they're in your gift cards and, you know, whatever else that's just kind of around. And the high coversity ones are actually very hard to erase, and this is because that they have a higher magnetic field of their own, about 2,750 Oersteds, whereas the LOCO ones, they only take a little bit of magnetic field energy to erase their information, and that's because they have a very low magnetic, they're encoded with a very low magnetic field themselves, which is about 300 Oersteds. This is important because the stronger magnetic fields in the HICO cards makes them more durable, and the data encoded on the strips are less likely to be unintentionally erased when exposed to the outer magnetic field. And this is why information on our credit cards and our debit cards and other things like that when they're exposed to a small amount of magnetic fields, like our phones, they aren't erased and we can still use them even if they're exposed to these small magnetic fields. Whereas things like gift cards, they can be erased and rendered unusable.
So we were surprised that our phones actually did damage the magnetic strip in the gift card. When we went to go try them, they didn't work. And I know from personal experience that I always keep my student ID and my license and my credit card in the back of my phone, in my phone case, when I don't carry a bag. So it was really surprising to see that they didn't work. But when doing more research, we found that gift cards do have a weaker magnetic field. So it kind of makes sense because my credit card, for example, has the chip, so that would be protected from the magnetic field from the phone. And also, I've kept my ID in my phone for the years that I've been here, which is 2 now. So, for example, I had an advising appointment, and to go swipe your card to sign in, it did not work. However, when I go to swipe in for my dorm, it does work. So it did damage the magnetic field in my student ID card. So if you have a HICO strip on your card, the chances of your cell phone damaging your card is highly unlikely, but it also depends on how long your card was exposed to your phone, how close it was, if it was directly by your phone, or if there were things in the way that could also have an effect on it. So it's safe to say that if you keep your credit card or debit card in your phone, it will not damage it because the magnetic field is stronger in those cards, but for a gift card, it probably will damage.
So, our group is looking into how magnets of different strengths, for example, we used a phone as a weak magnet and then a stronger magnet from our physics lab, and see how they affect the magnetic strip on gift cards. For example, we used Meijer gift cards. We also wanted to look into the difference between the magnetic strip and the magnetic chip that's found on debit and credit cards. Now, a lot of people know that the magnetic chip is a lot safer and protects your information well, but here's why. The magnetic strip on the older cards can be read solely by contact with a strip reader, making the information really easy to get a hold of. When you swipe the card with the magnetic strip, the processor reads the magnetic field and matches it to your bank account and has all your information already just like that. The issue is that this information is static, meaning it's a lot easier to get a hold of. It's a lot easier for people to steal it. Now, cards with magnetic chips embedded into them prevent the information from being stolen or damaged because they have to be inserted into a chip reader. They can't just be swiped or tapped or nearby. It has to be inserted completely into the chip reader. That's why a lot of the times people only put the chip in like halfway and the cashier would be like, oh, give it another push, and you gotta go all the way in or it won't work. This is because the chip reader has to read the information, like the PIN number and the location, everything like that. There's also data encryption embedded into chips. And so when you insert the chip into the chip reader, it goes back and forth. The chip reader understands the encryption and can work through it and get your information and double check that the bank account, location, PIN number, everything is secure and accurate. This means that anyone who actually does get access to your information, even though it's a lot harder, it is possible, but once they do have it, the encryption makes it a lot harder to actually understand it. With a magnetic strip, the information is just read as is. So it'll just say PIN number 1234, which is a horrible PIN number. But with a chip, the information is encrypted, so it's protected on 2 more levels in comparison to the magnetic strip. Banks all over the world are using chip rather than magnetic strips, and the US is actually one of the last countries to switch over to using the chips, but we finally figured out that it's a lot safer, and now we're protecting our bank information a lot better.
So another one of the kinds of cards that we've learned about is the ones that have an RFID chip in them. RFID stands for Radio Frequency Identification Chip, and these kinds of chips are usually found in cards such as driver's licenses, Spartan IDs, the new biometric passports that are being released, and some credit cards. Those would be the credit cards where you have to tap to pay, where you can just kind of swipe them over the reader. You don't actually have to take it out of your wallet or anything. So like the name suggests, they use radio waves, not magnetic strips. So also the information isn't magnetically coded, which is why they use the radio waves instead. These chips serve more as like an identifier to locate the info with that's on it within an external system. So because they need radio waves, they're not actually affected by magnets. So that would explain why when you keep your phone in your pocket next to your like Spartan ID, your driver's license, or if you keep your passport on you, I don't know why it's not affected by that. It's also, fun fact, like not usually too worrisome about security with RFID chips because, like I said, they don't usually have the information actually encoded on them. It's usually in some external system, but because the information on them still can be read, because you don't need, like you just swipe it over everything. It can be picked up by nearby transceivers. So some people have invested in the RFID protected wallet cases, which are a bit overpriced, but that's none of my business. But those use the concept of electromagnetic shielding, which focuses more on the ideas of how there's no electric field within a conductor because of the charges canceling, which provides the perfect protection for your RFID chip enabled cards.